Hello and welcome everybody. Today is the day 22nd of our Smart 25 Days Challenge, and today we are going to make a to-do list smart contract. So let's now begin. So first of all, we would be creating our file as always. So let's call this to-do list only. To-do list, okay. Yes. Then check my solidity. Yes. Okay. So let's start building contract to-do list. So this is nothing sophisticated. Is as the name suggests, we would be making a to-do list a smart contract, which will allow any user, as we are exploring the use cases of smart contracts. So we are just trying implementations with what smart contracts can do. So we can make a to-do list with the help of this, and this will help a user track the number of the tasks which he or she wants to do, and then we would also be marking them as failed or marking them as that task has been completed. Okay, so we will allow the user to mark them as complete or mark them as failed, and that's it. That's going to be a pretty simple smart contract, but yet a useful one. So let's try to make this. And so the most important thing in this smart contract would be our task. Okay, so for that we would be defining a struct called as task, and the properties of this struct would be the description of the task. Okay, description. Then along with this uint deadline. So, and whether the task is complete or completed, or whether the task is failed. Okay, failed. Yes, so that's it. And so this is going to be our struct, the task struct. And what we are going to do, we would be allowing each user to have create multiple tasks. So what we would be doing is we would be creating a mapping which will associate the addresses with an array of task structs. Okay, and we would be making this public, and we will be calling this mapping as tasks. And now let's come to defining our events as we have been doing in the previous videos. So if you guys are having any confusion, or if you are not able to follow what I am doing, so please go through my previous videos. There I have explained each and everything in detail, and otherwise just keep on following. So at the event here we are defining is the task added. Okay, so the task ID, the description, and deadline. Okay, looks fine. Okay, cool. And another event would be the task complete, and the third event would be the task has been failed or something like that. Task failed. So task completed. Right. And the third event would be the task failed. Task ID. That's it. Let's make a function, that function to add a task, and we'll call this add task. Memory, description, deadline, external, and then just we would be defining the function. So checking bytes that the description should not be empty. This description dot length should be greater than 0. Okay, and we'll say description cannot be empty. Yes. So another required condition would be that the deadline should be greater than 0. Okay, and we'll say the deadline because at least some seconds should be there. Okay, so we are taking the deadline in terms of seconds greater than 0. Or we can even define here deadline in seconds. Okay, in seconds. So here also deadline in seconds. Okay, and then a unit actual deadline, then we would be creating calculating actual deadline. That would be deadline in seconds plus block dot timestamp. And then we would be accessing this task mapping, and we would be accessing that by using the key address as the key, and then the array. Into the task array we would be pushing the new task struct. Okay, as soon as the user creates a new task, so we would be pushing that into the task struct. Okay, struct of task struct an array of task structs. Okay, so we would be pushing that task struct into this array, and how we are going to do that in the is in this manner: sender dot push and task description and then actual deadline, because we need description then deadline, then is it completed or is it failed. So initially they both would be false, that it's neither completed neither failed. Okay, so then actual deadline false. Okay, looks cool. And that's it. So now new task id. The task ID would be the length of the array. Okay, tasks in this, and message dot sender dot length. Okay, and then emit task edit, and in this task edit, the task ID would be new task ID. The description would be, okay, let's make it small only. The description would be this description, and the okay, and the deadline would be actual deadline. Actual deadline. Okay, looks good. So this is how the first function add task should be written, and so now this is complete. So we have defined our first function, then now define a function to mark the task as complete. Complete task. Okay, and the parameter it would be taking would be a unit task ID. Okay, external. Yes, so the required conditions that we would be checking is, so to mark a task as complete, first of all, the task ID. The task ID should be less than the task in the length of this task structs, basically less than or equal to tasks message dot sender dot length. Yes, otherwise we'll say invalid task ID. Then another required condition would be that the task should not have been already marked as complete. So we would be checking task message dot sender, and then the task ID. Okay, the specific task ID and dot complete. Dot complete. Completed. Okay, yes. So that's how. Okay, and now we'll say task is already completed. Another required condition would be, so here what we are doing is, so we are checking for a specific for the message dot sender. Okay, for a specific address we are accessing the associated the array of task structs, and in this array we are accessing the the task struct stored at a particular task id, and then in that by accessing that task id, that means where the index of the task struct stored in this array. So this task id is basically that only. And then what we will be doing, so the index that we would be accessing the associated task struct, and in that task struct we are accessing the completed property, and we are checking whether it's marked as completed already or not. So that's how we are going to check for the other condition, that is failed to also. So in the similar manner we can just copy it down, so you can see okay. So task id dot failed is failed, yes, cool. And we'll say task is already already marked as failed. Okay, and that's it. So yes, so we would be moving forward, and then if everything goes fine, so in the tasks mapping associated with a particular message dot sender, okay, this is the key, then this is the particular task the task struct, and then mark that as completed equals to true. That's it, and then emit the task has been completed. This ID. Okay, looks cool and fine. So that's it for the complete task function also. So now let's make a function to mark the task as failed. Mark task or just failed, or you can call this mark task as failed, or just keep it simple and mark a failed failed task. Okay, f small f failed task. So that's it, and then just it would be taking the task ID external, and then what it would be doing, it would be also checking for these conditions. So we'll just copy them and just paste them. So the task, the length should be this only. Okay, the task could not be already marked complete, and it should not be marked as failed. One more thing we would like to add here is that the task, the deadline should have been passed, because we'll say that you, if the user is still having time, so he can perform the task. So there is no need to for him to mark it as failed. So we'll check whether the deadline has passed or not. So we'll check for that. Okay. Task ID and dot deadline. Deadline has not been reached. Okay, so yeah, reached only. Okay, looks cool. So this is how we will proceed with this function, and then everything, if everything goes fine, then just message dot sender, message dot sender, and with the associated task struct, and this mapping with the, okay, so a specific task struct, and then dot field field equals true, emit task field, so, and the task id. Yes, that's it. So that's how our this field task function would be completed. And now let's make a function to just get the task count for a specific user. Returns the unit only, and so this will just return the length of the array of tasks. Okay, so tasks message dot sender dot length, and dot length, okay, looks okay, so dot length, yes. So this is how, okay, this get task count function will work. And for getting the specific task, or knowing the details about a specific task uint task id, yes, and it would be external, only a view function returns string. So the things it would be returning would be a string uint, because it would be returning description, deadline, then bool. So uint bool, then bool again. So that's it with this. And so the required condition would be check for the valid id. Okay, task id should be a valid one. Okay, yes, looks cool and fine. So, and if everything goes fine, so this create a task struct here called so a variable of task struct data type, and call this variable as small task k task, and then from the tasks mapping just retrieve the value message dot sender associated with the particular address, and then associated with that, and then the task id, that means the specific struct is stored in this, and then just return 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 task, this task dot. So by creating this, we would be able to access the properties of this specific task struct, and then just task dot description, then task dot deadline, then task dot completed, and task dot paid. So the details about a specific task, and then just, okay, nothing else. So this is complete, and so now looks like our smart contract is now complete. So we can just test it out. Okay, so let's first compile and then deploy. So let's try to test it out, what happens. And you can see a specific user can just, okay, so finish the homework, and say the deadline for this for just testing out, let's say it is 60 seconds. Okay, so let's just click on transact and see what happens. Okay, so you can see, so what will happen is, okay, so just click on transact and see. So this gets executed, and now we have the task ID. The task ID is 1. Okay, so description of the task is that finish the homework, deadline is this, and then the user can just mark that is complete or not. Okay, so that's how the user can do this. And So for getting the count, for a specific user, this is that means only one active task, and this here is here, and that's how a user can just interact with it, and he can just say he has done the work, so he can mark this as complete. Okay, so let's see what happens. Task ID is complete task. Okay, invalid task ID. So actually, I was making a small mistake here. So actually, during the implementation, when we were adding the task, so the new task ID, we had kept it as the tasks message.sender.length. So what was happening here is that the task ID is actually when we are adding the first task. Okay, so the index at which that gets stored, it is at zeroth index. Okay, so at zeroth index, when a particular task struct gets stored, but for the user, we were telling that it is stored at the index number one, because the length of that array, the length of the task structs is one at the time when the first task struct is added. But the actual index at which it is stored is this the length of the array minus one, so that means at zeroth index. I hope I'm clear, but so this was a small mistake which we were making in the implementation, and now the everything should work fine. So let's just try to compile and deploy it again. So just compile, deploy, and let's see. Okay, so in the add task, let's say something important, and then the seconds, say 20 seconds, and let's see. Okay, so here you can see the user can check. Okay, the ID, task ID is zeroth, and now let's try doing that and marking this as complete, and see it gets successfully executed. So, and the details also the user can know the task, and you can see. So this means that it's working fine. This bool is marked this completed bool is marked now true. So that's how this smart contract works, and that's it from my side, guys. You can always test it out, play with it. You can add additional functionalities to it, and I would recommend you doing that, trying it out. So we'll meet on the day 23rd of our smart 25 days challenge. Till then, bye bye.